Welcome to Quick Engineering. The topic of today's video is Introduction to Finite Automata. In this video we will see what is finite automata, structure of finite automata and types of finite automata. So let us start. What is finite automata? Finite automata is a abstract mathematical model which is used to process the string. So to process the string, it takes the string as input and produces output. So it accepts discrete input and output. So the output is discrete, input is discrete, discrete mean difference, and output is also different. So to process the input, it will go through various number of states. It uses various number of states. So the diagram of finite automata will be like this. From left hand side there are input symbol are passed to number of states. So there can be any number of states. So here there are q0, q1, q2 up to qn. You can give any state name, but if you go through standard books you will find this convention q0, q1, q2 up to qn, and this input symbol is processed and then it will produce output. So even if it accepts the string but the symbol are processed one at a time, so it accepts the input in the form of string and read only one symbol at a time. So this is the example. Here there is string hello. So if finite automata process this string, then it will be in the form, first of all it will read h, then it will process e, then it will process l, then it will process l, then it will process o. So it reads one symbol at a time and it provides whether the string is accepted or not. Since I told you finite automata contain various number of states, so there are various naming convention to represent the number of states, to represent the state. So initial state is represented like this, circle and arrow. Okay, and here you have to give some state name. You can give any state name. So since it is initial state, the state name is q0. Then if you want to represent final state, then provide double circle. So double circle represent the final state. So let us see the structure of finite automata. Finite automata contains states, transition and input symbol. So let us see what is transition and what is input symbol. So here there are three states, q0, q1, q2. q2 is the final state, q0 is the initial state. Okay, so arrow is represented here. So to move from one state to another state there is transition. So this arrow is called as transition, and then over transition there are input symbols. So there are two input symbols. So this is the structure of finite automata. Finite automata contains state, transition, input symbol, and there is initial state and final state. Now next is types of finite automata. So there are two types of finite automata: deterministic finite automata and non-deterministic finite automata. So there is one basic difference between DFA and NFA. In deterministic finite automata, for one input symbol there is only one transition. Means here in this diagram, if you see q0, if you look at q0, q0 has input a, so it will reach to q1. Now there is no other transition for it on q0. If you look at q1, q1v is q2, so there is no other transition for v on q2. So that's why it is DFA. But in NFA there can be more than one transition for the same input symbol. So this is the basic difference. Second difference is NFA has two type: NFA with epsilon mu, NFA without epsilon mu. Okay, but epsilon means null symbol, but in DFA there is no epsilon mu. So this is the second difference between DFA and NFA. So we will see this NFA and DFA in next upcoming videos. So that's it for this video. If you like the video, please subscribe, like and share. Thank you.